All right, here we go. 4.5. A number r is a square root of a number s if r squared equals s. The expression, the square root s, is called a radical. What's underneath the radical sign is called the radicand of the expression. So, for example, 5 is a square root of 25 since 5 squared equals 25. And if you look at our warm-up that we did, the square root of 49 is 7 because 7 squared equals 49. Alright, then we have two properties of square roots. The product property says that the square root of a times b is equivalent to the square root of a times the square root of b. You can use this property from left to right or right to left. If you have square root a times square root b, you can make it square root a times b. We have the quotient property, and that says that the square root of a fraction, a divided by b, is equivalent to the square root of a divided by the square root of b. Okay, so there's your product property, your quotient property. Then we have 3 rules for simplifying square roots. And here they are. Number 1, no radicand has a perfect square factor other than 1. Okay, this is number 1. No radicand has a perfect square factor other than 1. Well, something we might want to talk about is what is a perfect square factor? Perfect square factors are numbers like these: 1 squared, 2 squared, 3 squared, and so on. The other thing is I just defined for you on the first slide the radicand. When it says no radicand, so I'm using new vocabulary here. So what is a radicand? We just wrote it down.
Is it the first number, like the 5 or the 25?
What's underneath the radical sign?
It's what's underneath the radical sign, okay? Because I'm going to use the word radicand a lot, and I need you to understand that radicand is what's underneath the radical sign. Alright, so what's underneath the radical sign can't have one of these factors in it other than the 1. Number 2, no radical in the denominator. 3, no fractions underneath the radical. These are 3 criteria that are considered unsimplified. So in example 1, it says simplify the expression. And I'm going to show you 2 methods, okay? I'm going to show you if I have the square root of 80, I know that that is, and I'm going to use my product property here, the square root of 16 times the square root of 5. So that's 4 square root 5. That's one way to do it. If you have really good number sense, this might be your best route, and it's fast. The other route is this. Do you guys happen to remember what a prime number is? What's a prime number?
Yeah. A factor, or a factor. A number that can't be multiplied anything times it won't multiply to it. It can't be divided any more than this.
The only number that can be divided is 1 in itself.
Okay, yeah, I mean, you're right, but if we just kind of tidy that up, it only has factors of 1 times itself. Now, it only has 1 in its unique self, so 1 is not a prime number, okay? And that's a sneaky ACT question, just to give you some help in your future. They will ask you something like, what are the prime factors? And one of their wrong answers includes 1. 1 is not a prime number, but you're talking about like 2, 3, 5, 9, 7, 11, then 13, then 17, 19, so on, okay? So anyway, what you can do is you can take prime factors into your number. If you know it's even, that means 2 goes into it. And then you want to bubble your prime factors. Well, that's still even. So it's 2 times 20. 20 is 2 times 10. And this one's 2 times 5. Okay, so now I have all prime factors. And here's what another teacher has said is, if you have a pair, they're buddies and they can go out. So I have a 2 that came out. I have another 2 that can come out. Well, 5's all alone, so 5 has to sit at home, and it has to sit at home under the radical. So it's 4 radical 5. So pairs can go out because they have a friend, they have a little buddy. And if there's a lone number, it stays underneath the radical like that. So you choose. I don't care which method you use. You use whatever makes sense to you. Now, letter B, I need to first multiply this together and get the square root of 126. All right. If you want to use the method I like, let me remind you of something, a divisibility trick that I know you learn in elementary school, like 5th grade. If you take 6 plus 2 plus 1, that's 9. If 9 goes into that sum, like if it added up to 18 and 9 goes into 18, 9 goes in the number. Did you guys remember that?
Yeah.
I know it's been like 4 or 5 years, so if not 6 years. So that's what, it goes in there 1, 14, so then that's 3 radical 14, if you like to do it like that. Alright, then in letter C, I'm going to use my quotient property and break it apart as the square root of 4 over the square root of 81, and that's 2 over 9. In letter D, let's make that the square root of 7 over the square root of 16. So that's the square root of 7 over the number 4. Notice, if I check my list for simplifying square roots, I've met criteria 1, 2, and 3 in each of these. Okay, so now let's look at example 2. Letter A, the square root of 27. What's the biggest perfect square factor that will go into 27? 9. So we'll make it the square root of 9 times the square root of 3. So that's 3 square root 3. Alright, when I'm looking at letter B though, boy, nothing's jumping out at me, but it's even. So 2 goes in there. 2 times what?
49.
Oh, isn't that nice? Because 49 is a perfect square, isn't it? So that's 7 square root 2. In letter C, we need to use the product property and make that the square root of 150. And then what perfect square factor? Yeah, 25 goes in there 6 times. So it's 5 square root 6. So that's square root 15 over 2. Alright, any questions on example 1 or example 2? Alright, then rationalize the denominator. You need to write this down. Rationalize the denominator means eliminating the radical in the denominator. Well, if we have sums and differences, you need to multiply by what's called the conjugate. And this should be a review for you, right? From Algebra 1. You should remember this. But I'm just refreshing your memory. A plus square root b and a minus square root b are called conjugates. You'll see why in a moment. So let's look at example 3. The first thing I'm going to do in letter A is I'm going to use the quotient property and make it square root 5 divided by square root 2. Well, okay, because we can't have a fraction under the radical. The second problem is we cannot have a radical in the denominator. Now, this does not require a conjugate, though, because I don't have a sum and a difference. A sum or a difference. So you just need to multiply by square root 2, because what's square root 2 times square root 2?
2.
It's square root 4, which is 2. So my numerator, though, is square root 10. in letter B, since I have a sum in the denominator, I'm going to multiply by the conjugate, and let me FOIL it so you can see why we might want to do that. Leave your numerator factored. Do you guys remember, what does the word factor mean? Rewrite as multiplication. So I'm going to leave the numerator factored as 3 times 7 minus square root 2. Then I'm going to FOIL in the denominator. 7 times 7 is 49. But watch what happens with my outer and my inner. I get a minus 7 radical 2, and the inner is a plus 7 radical 2. They cancel. That is the purpose of a conjugate. They're going to make the radical disappear. And then I have a positive times a negative, which is negative. And what's radical 2 times radical 2? 2. Radical 4, which is 2. So this is 3 times the quantity, 7 minus radical 2 over 47. Nothing cancels. Sometimes the 3 will cancel with the denominator, but you don't need to multiply out the numerator. Excuse me. Thank you. All right, let's multiply by the conjugate. Since it's subtraction in the bottom, we're going to multiply by the addition. So it's 4 times the quantity, 5 plus radical 2. Leave it factored. In the denominator, let's use FOIL. And I'm going to get 25. The outer and inner cancel, and I get minus 2. So my final answer is 4 times the quantity, 5 plus radical 2 over 23. Nothing will cancel. All right, now, letter D. We're going to first break this apart using the quotient property that says that's radical 2 divided by radical 15. Now, what I want you to notice is all rationalizing is not created equally. If it's a sum or difference in the bottom, you do a conjugate. But if it is a single number, a single radical, you just need to multiply by that radical. So this is radical 30 over 15. Now, I want you to write this down. I have a what if question. Okay? What if I had given you 3 divided by the square root of 8? Yeah, Carmen?
You would still multiply by the square root of 8, so that the top would be 3 square root of 8 times 8. I mean, over 8.
Okay, and that is one way to do it, okay? You could still multiply by square root 8 over square root 8. However, we would have a problem, wouldn't we? What do you have with square root 8?
You can pull out a 2.
You can pull out a 2, can't you? Because square root 8 is 4. 4 times 2. So, my point of this example is to get you to think. I don't want you just to automatically process and say, this is how we do them. I want you to really stop and think. Okay, well, couldn't you, in this case, simplify the radical first, and so there's nothing wrong with what Carmel said, but we would then have to simplify the radical. Okay? I mean, what you said is correct. There's nothing wrong with it. But I'm trying to give you another option to consider. Is then, watch, we would need to, even though there's another 2 out front, you don't need to multiply by a 2 out front, because that has no effect, no bearing on your radical. So then this becomes 3 square root 2 over 2 times 2, all right, because square root 2 times square root 2 is 2, so that's 3 square root 2 over 4, like that. So just consider that when you have a single radical in your denominator, think about simplifying it first, okay? All right, now we're going to take the radical review and help us with solving quadratic equations. Now we're going to assume that s is positive, and if you have x squared equals a number, there are 2 solutions. x equals plus or minus the square root of s. So for example, if I said to you that I have x squared equals 81, that's actually plus or minus the square root of 81, which is plus or minus 9. And I want you to think about this a moment. If I take the positive 9 and I square it, 9 squared is 81. And if I take negative 9 times negative 9 is 81. That's why you need the plus or minus. Okay, it's going to create two solutions there. Alright, so let's look at example 4. What I want you to write though above it is you need to isolate the x squared. So let's start by subtracting 5 to both sides. And then you're going to divide by 3. So I'll subtract the 5. 3x squared equals 36. Divide by 3, x squared equals 12. So now x equals plus or minus the square root of 12. So here's the connection to what we were doing. When you're solving equations that have an x squared, you have to know how to simplify radicals. How does square root 12 simplify? It's 4 times 3, so it's 2 square root 3. I would love it if we could skip that square root 4 times square root 3 and go directly. Now we're Algebra 2 students. We should be able to do that. All right, try example 5. Isolate the x squared. The most common mistake that I see is students forget the plus or minus, okay? So I'm getting x equals plus or minus 2 square root 10. You guys getting it? Okay, just because of time, we're going to skip 1 through 8 on the guided practice. And I want you to do 9 and 10 and then pause so I can do 11. So try 9 and 10 on here. No, don't start 11. That's a little bit more complicated. Alright, so in 9, did you guys get x is plus or minus 4? And in 10, did you get z is plus or minus 6? Okay. In number 11, what we want to do is we want to isolate the x minus 2, the quantity squared, because I still have something is being squared. So I'm going to divide by the 3 and get x minus 2 squared equals 40 divided by 3. Okay. Now I have my something is being squared. So what I do is I take the plus or minus square root to both sides. Unfortunately, it's a fraction and an unpleasant fraction at that. So does everybody understand what I've done up to this step? Okay, now I'm going to multitask and I'm going to add 2 to both sides and I'm going to separate the fraction. Notice that we don't usually have a plus or minus in front and then a minus a number or an add a number, so you'll always put that number in front of the plus or minus, okay? So now watch, and here's where my what if question comes into play. I can multiply by radical 3 over radical 3, but that's going to create a radical 120, which is a big number, right? And that might cause me some difficulty. So what I could do instead is I can simplify the square root of 40. So this is true not just for the denominator, but also in the numerator. If any of your radicals in a fraction can get simplified, simplify them first. So 40 is 4 times 10. Now let me rationalize by multiplying by square root 3 over square root 3. So x is 2 plus or minus 2 radical 30 over 3. Now that's not a common denominator, okay? They don't have a 3 together. That first number is literally a 2. Okay, so that one was pretty tough, and you are going to have some like that in your homework. All right, questions on 11. So remember, as you're doing your homework, and if you get one, come back to this and say, how did we do that? Try to look at step by step. All right, last topic is something that's related to physics, and it's called modeling dropped objects. When an object is dropped, its height h in feet above the ground after t seconds can be modeled by the function h equals negative 16t squared plus h sub 0, where h sub 0 is the object's initial height in feet. There is also another formula, and it's in your textbook, but let's go ahead and write it down. This formula is h equals negative 16t squared plus v sub 0t plus h sub 0, where v sub 0 is called the initial velocity. Well, velocity is that force with which you're throwing the ball, whether you're throwing it up or down. If you are dropping it, do you understand that v sub 0 is actually 0? And so this formula, the one that they gave us, is really modified from here. If you drop it, you're not sending it with any kind of force. So 0 times t is 0, and that's what happened to that term, okay? But anyway, this is something you'll use in physics, okay? And you probably saw it in physical science, I would have thought. All right, in example 6, it says, for a science competition, students must design a container that prevents an egg from breaking when dropped from a height of 50 feet. How long does the container take to hit the ground? So let's start with the formula that they gave us. And let's play the what do we know game. Okay, here's our formula. And if you reread the problem, what do we know?
It's dropped from a height of 50 feet.
Okay, it's dropped from a height of 50 feet. How does that help me, though, in the formula? That is not actually the h.
Well, the other h.
The h sub 0, right?
Yeah.
Okay, the way we say that is h sub 0. That's the initial height, right? And what are they asking us to find? What letter? Are they asking us to find h? It says how long?
T.
That's t. All right, so now wait a minute. We're saying we have h sub 0 is 50. We're looking for t. I see no other number in here. But they had to have given us enough information to tell us h.
0, because it's ground level.
Okay, good. And this is one of those duh moments that you went, oh yeah, I should have had a V8 today. If it hits the ground, isn't h 0 on the ground? Oh yeah. Okay, so watch this. The height at the ground is 0. I'm looking for t, and the initial height is 50. Now we're going to make a beautiful connection to solving equations by square roots. So let's add 16t squared to both sides. And then you're gonna definitely want your calculator out, okay? So let me pull mine, and we're gonna take 50. Let's take 50 divided by 16, and I'm going to show you a really neat feature on your calculator, okay? You're going to get 3.125, and then we want to take the square root of that, right? Watch what you can do. You can hit second, the x squared, and then do second, and then down here at the negative says the answer. So if you have some big long decimal and you don't want to retype it, you can always do second and the negative button, and it will punch the number in for you. Isn't that cool? So take 50 divided by 16 and press enter. Then you do second, square root, second, negative, and press enter. So the time is about 1.8 seconds. Now keep in mind, you really would have gotten a plus or minus, but you cannot have negative time. That doesn't make sense.